To solve some of the hardest math counts problems, we don't need any fancy math. We don't need any brilliant insight. We don't even need any magic. We just need careful attention to detail. And you know what kind of problems I'm talking about? I'm talking about those casework counting problems. We're going to tackle a couple of those this month. We're going to start right here with these 15 circles. We want to count the number of sets of circles A, B, and C such that A encloses B, encloses C. Now to talk about all these circles, we're going to need to name them. We're going to call these little ones in here, those are the smalls. Next size out is medium, next size out is large. And the big boy here, that's the XL, extra large. And we're told that A is bigger than B, which is bigger than C, because B is inside A, C is inside B. That tells us right away, A can't be the small circle, because we need circles to be inside it. And A can't be the medium circle, because I need two smaller sizes of circles to be inside it. So that means A has to be large, or A has to be extra large. And we're going to keep those two cases nice and separate here. No matter what happens, A has to be large or it has to be extra large. Now we're going to think about this case where A is large first. Now if A is large, then B has to be medium and C has to be small, because C has to go inside B. And there are two large circles here that could be A. And whichever large circle we choose, there are two medium circles inside. It could be B. And whichever medium circle we choose to be B, there are two little circles, two small circles there. It could be C. So we have two choices for A. For each of those, we have two choices for B. And for each of those choices of B, we have two choices of C. That gives us 2 times 2 times 2. 8 ways to satisfy this problem where A is large, B is medium, C is small. So let's jump over here to A is extra large. Well, now we know B still can't be the small because we need to put C inside. So B has two choices. We can have medium or large. Now if B is medium, of course C is small. C has to go inside B. But now when A is extra large, we have 4 choices for which medium can be B. Not just 2. We have 4 choices there, but whichever medium we choose, there are 2 smalls inside it. So we have 4 choices for B. For each of those, we get 2 choices for C. 4 times 2, that's 8 possibilities total in which A is extra large, B is medium, C is small. Now, if B is large, then C could be medium or small. I could split that into even more cases. But whenever I choose a large circle for B, I have 2 mediums and 4 smalls. That's a total of 6 circles inside that could be C. So I'm just going to put those together. C could be medium or small. And for each of the 2 choices for B to be the large circle, I have 6 choices of smaller circles that are inside it. So that gives me 2 times 6. It gives me a total of 12 in this case. That covers everything. This is the beauty of being organized in your casework. I can see right here I've hit every single possibility. A is large or A is extra large, and I've hit all the possibilities here. And I can also see that I haven't counted anything twice. These cases are distinct. They're separate. So I've done the gold standard of casework counting. I've counted everything once, gotten everything, and I haven't overcounted anything. I've counted everything only once. All right? Once and only once. That's the goal. So now I've counted everything once and only once. Now I just add up the results for these 3 cases. 12 and 8 gives me 20. Add on the other 8 gives me 28. And that's perfect. On to the next problem. I have this 3 by 3 grid here. I'm trying to put the digits 1 through 9 in here such that the numbers are increasing from left to right and from top to bottom. Oh boy. I want to count the number of ways we can do this. Now, the only thing I know right away is I've got to put a 1 right up here. 1 has to go there because I can't put anything to the left of the 1. I can't put anything above the 1. So we have to increase going top to bottom and left to right. If I put the 1 over here, there's nothing I can put to its left or above it. So the 1 goes right there. Of course, then I think, well, where does the 2 go? I only have 2 options for the 2. I can put the 2 right here, or I can put the 2 right here for basically kind of the same reason 1 has to be in the upper left. If I put the 2 right there, well, there's nothing remaining that can go in the center square, because the 1's already up here. There's nothing less than the 2 that can sit right there. So I know that the 2 has to go here, or it has to go here. Now I could split that into 2 separate cases. But instead of doing that, I'm going to notice that those two cases are basically the same. Now, any grid I fill out that starts with a 1 here and a 2 there, I can flip it over the diagonal here, boom, and get another one where the 1's here and the 2 is there. So in order to count both of these cases, I'm just going to count one of them. 1's here, 2's there, and then I'm going to multiply by 2 in the end. So I can just flip it over. I'm going to write that times 2 up there so I remember to multiply by 2 at the end. Now I just have to deal with this. That's a lot of talking just to get 2 numbers into our grid. On to the third number. Where does the 3 go? I have 2 choices for the 3. I can put the 3 right here, or I can put the 3 right here. Just like with the 2, I can't put the 3 right there, because then what would go there? Or what would go there? I already used the 1 and the 2. So now I'm going to split this into 2 cases. One case has the 1, 2, and the 3 running across the top. And the other case has the 1, 2, and the 3 bunched up in the corner. 1, 2, and the 3. Now up here, we immediately know where the 4 is. The 4 has to go here. Can't put the 4 over there, because then there would be nothing left that I can put there, and so on and so forth. If I put the 4 here, there's nothing I can put above it or next to it. 4 has to go right there. But now I have options for the 5. 5 can go here, 5 can go here. So let's look at those 2 options. First we'll put the 5 in that center square. 1, 2, 3, 4, 5. And then the other option is 5 in that lower left square. 1, 2, 3, 4, 5. All right, up here, what are we doing? All right, well, if I put a 6 right there, then I have to go 7, 8, 9. All right, so that's one possibility. Now, the 6, I can't put the 6 here. I can't put the 6 here because I don't have anything remaining that I can put to the left of it. So the 6 has to go there if it's not up there. The 6 goes here. Well, then the 7, you know what? I'm just going to go ahead and put the 9 in here because I know the 9 goes in the lower right for the same reason the 1 goes in the upper left. So if I put the 6 there, we go 7, 8. If I put the 6 here, then the 7 can go here or here. So there's 2 options there. So once I have the diagram down to this, I have 3 possibilities. The 6 can go here, or the 6 goes here with a 7 going in either one of these. And 8 goes in the other one. So we've got this case, finally, we have one case settled. Now down here, once again, I'm going to go ahead and drop that 9 in the lower right. The 6 has to go here. It can't go here or here, because then we wouldn't be able to put the 7 or the 8 in the center square. Once you put the 6 here, well, it's clear we can go with the 7 there or the 7 there. We have 2 possibilities. So now we've worked out this whole strand, and we know that there are 5 possibilities total along this once I put the 4 there. All right, this case. Now I got 3 possibilities for the 4. I could put the 4 up here next to the 2. 1, 2. Put the 4 right there with the 3. Or I can put the 4 below the 3. 1, 2, 3, 4. Or I could put the 4 right there. One, 2, 3, 4. Wait a second. This is the same as that. This is exactly the same as this. Numbers are already filled in the same places. We can put the 5 here, and we'll get something that looks like this. Or we can put the 5 down here, we'll get something that looks like that. We've already solved this problem. Now, it doesn't matter that we switch to 3 or 4 here. That doesn't change the possibilities for the 5, 6, 7, 8, or 9. So we already know that there are 5 that work right there. And we've already solved this one, because this is basically the same thing, except it's turned on the sides, flipped over the edge like this. Instead of having the top row and this filled out, we have the left side and this filled out. We can put the 5 here, and we'll end up with 3 across the top, 3 across the side, just like we had there. Or we can put the 5 in the center, and we'll end up with basically the same situation as here. So this is exactly like this when we're counting out all the cases. We go ahead and split this into 2 cases. I'm going to draw it out. I don't think you believe me. So let's see what happens if I go ahead and draw this out. If I go ahead and draw the 2 cases we have here where the 5 can go. I can put the 5 up here, 3, 4, and this 9 will go here, the 6 will go here, and that looks just like this. That's 2. Or I could have taken the 5 and dropped it in the center square. Put the 3 there, put the 4 there, drop the 5 in the center. Then I have to put the 9. And now I have the 6 can go there, and we go 7, 8, or the 6 can go up here, and the 7 can split into either one of these. So there's 3 cases here. That looks just like this. How do you believe me? So we have 5 in this case as well. 5 total here. So we've taken care of these 2 because they're the same as this one. That's really nice. Now once we get to this, well, now we have 2 choices for 5. I can put the 5 down here, or I can put the 5 up here. Now if I put, let's see what happens. If I put the 5 up here, well, now I have something that looks a lot like this. We drop the 9 in here, and on we go. Looks just like this. We're going to have 3 possibilities. Or I could have put the 5 down here, and then I'm going to end up with something that looks just like this. And we're going to have 3 more possibilities. So this whole arrangement gives me 6 total when I go this direction. So if I start from here, I get 5 that look like this, 5 that look like this, 6 that look like that. Gives me total 16. So I have 5 when I go this way, 16 when I go this way. That gives me a total of 21. And then I remember that times 2 up here for we flip this over and go 1 on the top and 2 right below it. Multiply 21 by 2, you get 42. And that's the answer to everything.